one side that has that non-slip padding on it, and I tried it first. Well, it started off with no padding, and it just there's no friction. Like it doesn't stick to the wall with just four posts there. Then I tried padding on both sides, but that doesn't allow the foot to slide on the surface. The padding on the back of each foot is there, so when it tries to peel off the wall, so that force puts everything on the back of the foot, puts everything on that non-slip pad. So that's why it's able to stick a little bit more. Now, if you can hear all the motors whining, and a motor will whine when there's power to it, when there's some signal going into it. So the four motors that are whining are the ones on the feet. What that is that in order to get enough force on it for it to walk, each of those motors is applying a force backwards. It's pulling the magnets off the surface, but not enough force to actually separate the two. It's applying a force out, which is pushing the foot down.
So you programmed it so that when you release the remote control on it, it automatically puts reverse power on it to the extent that just enough to give you the adhesion you need.
Now the programming of this, if you're interested, I've got the laptop with it. There's two functions. I made two user functions that describes everything this robot does. There's one that is legs, and if you notice, there's the legs move together. This leg and this leg always move together, and this leg always move together. I'll get there, Josh. So there's that set. There's one function that describes leg movement, and one describes the magnets. So on my remote, I've got a couple different. I can go forward, pulling off, hopefully. So that is one step forward. That was just pushing this joystick up. I can also shift left or right, and I'm going to shift left. I better shift right. And that was a full shift. Now the reason the first set of legs didn't take a step was that these potentiometers give an absolute position of these legs, and the program sensed that these legs were already in the final position. Like they couldn't move.
Go right again.
Somewhat straight up and down. It's turning a bit, but you're resistance.
Yeah, it's not that much.
And I go down. So this is all based off remote control functions. Because this is all this timing right to drive it, you couldn't worry about anything else. I don't know if it's possible to get everything you need to get done here. So it's all based off remote control input here. I also have, when it's done walking, I can press one button.
You got lucky.
What that button does is it locks all the feet down. The issue is have any sensors on the feet. So when it goes, it actually pushes the robot off the wall and then sucks it back in, to make sure that it gets in contact with it. So that's why that 1 foot, it lost the non-slip padding. It was just on the magnet, so it slid. It still had adhesion, so it's not gonna fall off, but that's why it slid. And this leg was the last one to go, is why this one stayed in contact.